When you need mealtime inspiration, it's worth shopping Kroger for thousands of appetizing ingredients that inspire countless mouth-watering meals. And no matter what tasty choice you make, you'll enjoy our everyday low prices. Plus, extra ways to save, like digital coupons worth over $600 each week and up to $1 off per gallon at the pump with points. So you can get big flavors and big savings. Kroger, fresh for everyone. Fuel restrictions apply.
This episode is brought to you by Shopify. Forget the frustration of picking commerce platforms when you switch your business to Shopify, the global commerce platform that supercharges your selling wherever you sell. With Shopify, you'll harness the same intuitive features, trusted apps, and powerful analytics used by the world's leading brands. Sign up today for your $1 per month trial period at shopify.com/tech, all lowercase. That's shopify.com/tech.
Hello, it's Gareth. This is the Somewhere on Earth podcast for Tuesday, the 12th of November, 2024. And here we are again via your favourite podcatcher and, of course, via the Evergreen Podcast Network. You can find out more about Evergreen and the various many brilliant podcasts from that community via our website. So just go to somewhereonearth.co and click on the Evergreen logo. And coming up today, well, we have quite a lot about generative AI and chatbots this week, including how chatbots get it wrong in one of the most widely spoken languages in the world. We'll discuss the implications. Zut alors. Well, there's a bit of a clue. Also, how to train a robot to jump over obstacles and other stuff that might get in its way without ever exposing the bot to the actual real world. So not even photos or video of anything from the real world. How do they do that and get the robot to do what it needs to do? It's a really cool piece of research from MIT. We'll tell you all about it right here on the Somewhere on Earth podcast. And keeping me company today is the excellent Ania, producer, editor, CEO, the boss, basically. Hello, Ania. You're enjoying?
Yeah. That's me, apparently.
This week.
I am. I quite like that. I'm not just oi you or oi mama.
Is it? Yeah, I don't think I've ever done an oi mama on you. I guess you get that at home, but yeah. Maybe I'll take to that.
I've got to the point where I don't respond on that one either.
You've just given up caring. Now, according to the language learning website Babbel, or maybe Babel, I think it's Babbel. Anyway, French is one of the fastest growing languages in the world. About half of all French speakers live in Africa. It's the official language in 27 countries. So when you find out that French language AI chatbots give the wrong answer a quarter of the time, that's quite a lot. That is a big problem, given the rising popularity of such bots and the ubiquity of the French language. And if you're not a French speaker, this still matters to you. This is a big chunk of the information ecosystem that is really having a few problems with these inaccurate chatbots. Now, the anti-misinformation news organisation NewsGuard have just published a report about this, and our very own Ania has been speaking to Chine Labbé, and she is one of the report's authors.
Basically, what we found is that the chatbots in French language fail to provide accurate information in about a quarter of the time, in 25 approximately % of the time. What does that mean? That means that they either provide misinformation, so they will repeat a false narrative with authority, or they will basically not respond to the question and fail to provide any kind of information. We decided to describe as fail rate, non-response, plus misinformation. Why? Because we think that when a chatbot is not providing information at all, if it's saying, well, I can't respond to that question because of my, my knowledge cutoff, or, well, I can't address that because I'm not allowed to talk about politics, that doesn't really help you, does it? And actually, it can really contribute to the problem, because if a user wants to search for an information about a very sensitive topic and is just told that, well, the chatbot can't help him with that. That really won't solve the problem at all. So that's what we found. Now, 25% of the time is a lot. In terms of misinformation per se, the 10 leading chatbots repeated misinformation 13% of the time. I think some people might consider that that's not a lot, but basically take the analogy of a box of aspirins. You wouldn't want 13 out of 100 pills to be poisoned, would you? So we think it's a lot, and that shows that there is a big problem, especially because what we try to show with these monitors is that, well, of course, it's not to show that any user will find misinformation when they use the chatbots, but it is to show that they are easy to weaponize. And what is worrying in that report, specifically in French, but actually we're seeing the same trend in English, so we'll have to see if it's the same in other languages. But basically, what we find is that chatbots are particularly vulnerable to spreading misinformation when they're asked basically to produce misinformation. So we're putting ourselves in the shoes of a misinformation provider. Imagine a propagandist of the Kremlin or a propagandist of any foreign country that you might think of.
You mentioned the figure 25% of the time there's misinformation of some sort, either by lack of it or something that's being repeated that's fundamentally wrong. But some chatbots were really bad, weren't they? What was the worst case you found?
So the worst performing chatbot in French had a fail rate of 66%,
wow,
which is huge. And when it comes to just repeating false information, so spreading a false claim, one of the chatbots did it 40% of the time. So I think if we're looking, yes, at the overall number, 25% of fail rate and 13% repeating misinformation, some people might, brush it aside and say, well, that's not that huge of a problem. First, I think that's wrong because, if you take the drug analogy, you don't want chatbots to contribute to our misinformation problem, which is already huge. But then some of those chatbots are doing worse than others. And I think what we should realize is that it is possible to put guardrails. It is possible to do better. First, because we're seeing inconsistencies between the chatbots. We're seeing inconsistencies between languages. So some are doing better in French than in English. And why is that? We don't really know. Probably have they put more guardrails? We don't really know. And some of them are improving consistently in our monitors. We did this French one just as a one-off for now, but we're doing those English ones month to month. And we're seeing one of the chatbots has improved, for example, consistently over the month. One of the chatbots has a debunk rate of 100% in October. So we are seeing that it is possible to do something. It is possible to improve, but there is still a huge problem. And I think it's important to say also for your listeners, even though it's not about the French one, but again about English, the latest monitor that we've released has a fail rate of 46% versus about 30% in previous month, and versus 25% here in this French one. So this month, for some reason, and again, we don't exactly know why, they did worse. So we are facing a huge problem that's systemic of the industry, and we have to think of it as now is the moment to push for more guardrails, to push for more actions to be taken. It can't just be an afterthought. It has to be thought of as, we talk often about ethics by design. It has to be inputted into the chatbots as they are releasing new models and new versions.
What languages are next?
So I think we should look at more European languages. Interestingly, I sort of assumed before, when we went in doing the French language audit, that maybe the chatbots would be worse in French than in English, because the text that they are trained with there are just less of them, or I don't know, that was my assumption. But actually, interestingly, the bots performed better in French than in English, but only slightly, showing that it's actually as big of a problem, but interestingly, they were doing slightly better, repeating falsehoods 18% of the time in English versus 13% of the time in French, for example. So I think we have this assumption that AI chatbots are doing worse in certain languages that are spoken less, in which platforms and companies are investing less. So I think we have to test that assumption and check it, because it's only an assumption. So we have to look at some Eastern European languages. We have to look at Spanish as well. I think we'd love to do more in the rest of Europe. But I think what's next for us for sure is ahead of the AI summit in France. I think we're going to redo it in French, and perhaps look at other European languages that we speak in our company. Unfortunately, we don't have all the European languages. But I think, one thing that we've seen with platforms, for example, is that when it comes to content moderation, we've seen that the moderation was just much worse in certain languages, like from Eastern Europe, for example, than in English or in some Western Europe languages. Is it the same with chatbots? Are they more prone to repeating misinformation? We don't know. So we have these assumptions, we have these blind spots in terms of knowledge, and we have to fill them now that those tools are becoming really part of our lives, to make sure that again, they're developed with ethics ingrained in them and with guardrails to prevent their weaponization.
So that's Chine Labbé talking to Ania, and now I'm talking to Ania. We're all queuing up here. So it's one thing I picked up from that interview, Ania, is that a chatbot basically not answering a question is almost as bad, if not as bad, as one that's giving misinformation. That was very interesting.
Yeah, Chine was very clear that saying, I am not in a position to answer that, or I do not have enough information to answer that question, is just simply not acceptable. The advice there is to rephrase your question. So maybe just wording it differently will actually help. But if you still get a non-answer like that, then it could well be a company policy. A lot of the AI chatbots, particularly any political questions, have been staying away and ensuring that they just don't comment on that. It could be something like the data just isn't there, or the chatbot is unable to retrieve the data from your wording of your question. But also people say, this has been an issue when they put their own data sources in. And I know that quite a few of the AI chatbots have been trying to improve that particular feature.
One of these chatbots had a fail rate of over 60%, didn't it?
It's amazing, isn't it? I was just like, really?
That's rubbish.
We don't know which one, because NewsGuard do not identify which chatbot is which in their report. It's just called chatbot 1, chatbot 2, chatbot 3, etc., etc. So we can only see the differences between the different chatbots that they have tested. However, if you are a company, you can request the data from NewsGuard about their own particular chatbot, and hopefully the company could then use these findings to improve the AI.
Yeah, and indeed, as we heard from the interview, some of these chatbots are improving, so some of them are trending in the right direction. So another thing that jumped out at me was this call really for an ethics by design principle, which is great, but it's not as if anyone's going to say, well, I think we should have a kind of malice by design principle. You'd think that things like ethics and good practice, that should just be a first principle in any kind of design and any kind of product, shouldn't it?
It should, and don't get me started on the rubbish in, rubbish out.
Here we go.
Yeah, we'll be here for hours, so I will not mention that.
Right,
but
Mama.
if you... But... the EU Commission, they've been looking at this and advising on it for years. So in 2021, they produced a report called Ethics by Design and Ethics of Use Approaches for Artificial Intelligence. Now, their guidelines from that particular document for designing AI were respect for human agency, privacy, so personal data protection and data governance, fairness, individual, social, environmental well-being, to monitor all of that, and transparency, accountability and oversight, and declaring your sources. Where does that data actually come from that the AI chatbots will be using?
Yeah, all right. Ania, thank you.
The new Apple Watch Series 10 is here. It has the biggest display ever. It's also the thinnest Apple Watch ever, making it even more comfortable on your wrist. And it's the fastest charging Apple Watch, getting you 8 hours of charge in just 15 minutes. Introducing the all-new Apple Watch Series 10, now available for the first time in glossy jet black aluminum. Compared to previous generation, iPhone XS or later required. Charge time and actual results will vary.
Well, these links sometimes write themselves, but we're going to talk about another French word now, parkour. And it means the way through the path. I never knew what the literal meaning was, but that's what it means. And for me, that basically means watching crazy YouTube videos, the ones of people leaping between buildings, jumping down flights of stairs, or diving from bridges into rivers. So parkour is a sport. I think it has origins in military training, and it's about getting from A to B in the quickest and most efficient way possible. Now, we're not going to talk about the actual sport. You may be disappointed to hear about that, but this is even better. MIT researchers have been working out how to teach robots to do parkour or similar kind of pursuits using synthetic training data alone. So in this case, they're using a robotic dog, and it isn't quite leaping between buildings or jumping off bridges. But what it is doing is clearing like a fairly basic obstacle. They've just put like a little cone on top of some kind of wooden platform and trained this robotic dog to jump over it, and then the idea being that it could get good at doing that and then ultimately clear other obstacles. And I think it's fair to say, Ania, this is one of those AI stories that's a little bit complicated, but kind of simple when you get your head around it. Could we summarize?
Yeah, I mean, I have to admit, I spent the first 10 minutes of your interview with our guest. I was really struggling, and I struggled when I read the paper. There absolutely is, yeah. But I think where we pick this up from, it's going to work. So carry on.
I think it's going to work. It's going to be all right, especially if we set the listeners up for this. Right. So imagine like you're an AI researcher and you're trying to train a robotic dog to recognise and jump over an obstacle. As I say, like a little cone sitting on some kind of wooden platform. Like, how would you even start to do that? So clearly you need to show it lots of different examples of obstacles. So then its neural network soaks up all these examples as training data, and then hopefully every time it sees an obstacle, it knows what it is and it knows to jump over it instead of just running straight into it or whatever. But then how would you do that? Like, you could take it into the real world possibly, and then every time you see some kind of obstacle, you could activate a camera and upload the image into the dog's brain database. You could do, but that's not particularly practical. So another thing you could do, just back in the lab, is just get loads of images, plenty of Google image searches or whatever, of all kinds of different obstacles. You could do that and then just serve lots of images and videos and then get the neural network to soak those up as training data. But even that is not particularly scalable. So what these researchers have been doing is saying, well, hang on, generative AI is really good at generating thousands of images on a given theme. Like ChatGPT does this. I've tried it just now. I just gave it a few, like a little description, a prompt, saying, I think in my case, I said, design me a garden with reds and blues that is relaxing and with some birds or something. And it created what looked like the cover of a really nice greetings card. It was really beautiful. So that's what, one of these generative AIs can do. But then, okay, you need like hundreds of thousands of these images to train your robot dog. So you can't really sit there for hours just typing in just dozens and, just thousands of prompts, different variants on, I want an obstacle in a garden, I want an obstacle in the middle of a green field, I want an obstacle on a staircase. You just don't have enough hours in the day to create all the text prompts to go into a generative AI to use as the training data for your dog. Ania, do I make sense?
It is.
Going
it makes
so
complete
far so good?
and utter sense as once you've heard the interview. Yeah, I think it does make sense. Go. Anyway.
So we can cut to the interview now. Now, this is with postdoctoral associate Zhu Yang at MIT's Computer Science and Artificial Intelligence Laboratory. And I have a feeling when he plays this podcast back, he will say, Gareth, you did oversimplify it a little bit. So I hold my hands up. I have slightly simplified Zhu's, in fact, a lot simplified Zhu's work, but I think that's just we need to get into the interview and just understand the basics, and then he can tell you the real deal of what's going on. So basically, we began by talking about the generative AIs that you might want to be using to create all these different training images?
When people build these generative models, the goal wasn't to produce data to train robots. The goal was to make pretty pictures. But as it turned out, you put like a humongous amount of data into these models. Like take Stable Diffusion, for example. It's a text-to-image model that's responsible for making a lot of the pretty AI-generated human images you see on the internet. The original version was trained over 2.3 billion images, and each one of the image come with about 177 tokens. So that's about 400 billion text tokens. That's a humongous amount of data. And it turned out that these models, after training from this data, becomes a portable version of the data set. So the knowledge wasn't in the model. The knowledge was all in the data, but you kind of compress those data into these weights. And now you can have almost like a little search engine that gives you whatever image you want if you just tell it what you want. And that's a very powerful thing.
So you mean to train the robot dog, it needs to be very good at knowing not just what an obstacle looks like, but lots of different kinds of obstacles in lots of different settings. And so you could do it partly by taking it out into the real world and showing it some obstacles, but for obvious reasons that's not very practical when it needs to see 100,000 different cases. So you're using machines to help you generate the diversity of environments that this dog's going to have to deal with. Is that what you're doing?
Yes. So if you think about the dog trying to jump onto a box, right? There are two things. One thing is the geometry. Its foot is going to come in contact with the box, hopefully, after it jumps onto it. But then there's also the appearance, and the appearance doesn't just involve texture, whether it's made of a piece of a red brick or a wood. Those are texture, but there's also other things like lighting, whether it's wet, if there's water, if it's snowing, all of those things. It's very difficult to capture this level of complexity through a traditional means of computer graphics. And it also requires a lot of skill for someone to actually design a photorealistic 3D scene. But now with these generative models, it turned out that you can actually control what appears in the picture very precisely. And that's one thing we figure out how to do with this paper. If you try to affect the text-to-image generation process by the 3D geometry and what you want for each part of the pictures to be semantically. And it turned out that, a much better way to make these photorealistic, very rich visual data for the robot is by combining the classical, traditional computer graphics pipeline that involves, polygons and surfaces with a two-dimensional image generation model that takes in a depth image as a conditioning.
A lot of this presumably involves putting in text prompts, into
exactly.
Okay, and this is where I'm absolutely fascinated, because this is where you're using. Yeah, there you go, because this is effectively using a large language model to automate the process of creating the images that then go into the dog to help automate the way it can get past obstacles. There are lots of different levels to this. In other words, so tell me about the large language model that you're using to create the prompts that then go into the AI for it to create the training images for the dog.
This is really my favorite part of the project. I guess there are two ways to go about it. One way is to kind of take a step back and start to think about what's happening as a particular point in history. And I think we're at the point of history where we have a lot of the basic modules for building a very large machine learning power systems, where each one of the pieces is a an AI component, like an AI model. And you need some way to orchestrate these modules together. And it turned out that natural language is a very good glue logic to glue these different pieces together. So that's kind of the historical a backdrop we're in. In this case, the more specific reason why we actually try to generate those prompts using ChatGPT is because when we try to generate images from text, it turned out that after we start to apply a lot of these what's called a conditioning or control to the image generation process, you start to lose diversity. The typical way that people try to generate different images when they are using Midjourney or DALL-E is that each time they give it a different random seed. And when you're just trying to generate directly from text without controlling the geometry or the composition, it turned out that you can actually get very diverse images. But then we don't use these models that way. And when we actually apply the control and over-specify what's in there, we get like pretty much the same image with different random seeds. So we needed a way for what I call like to find the entropy. I need a way to farm entropy to put into my pipeline.
Right. So seeds, entropy, lots of terminology here. So the seed meaning, if you were to do the approach where you're very manually creating the image, you go into the polygons, you're really just constructing the image from the ground up. You could do it that way. You're saying, no, we're not doing it that way. Instead, we're using a large language model and we just use like language. We type into it the kind of things that we want it to do. And then we end up with a more diverse array of images rather than just the same old thing all the time that you might get otherwise.
The key is scale. Like I can try to come up with a text prompt myself, but then like in this case, I need like thousands of prompts. How am I going to generate like 1,000 prompts like sitting there? A couple of years ago when I was an intern at DeepMind, there was this retreat where one of the games was to have like the research scientists try to come up with like, I forgot what kind of text it was, against like the language models. And like the game was to see like if the research scientists were generating better text or the machine was generating better text. And this was back in like 2019, and the humans lost.
Wow, and that was in 2019. Okay,
that's right.
So let's go through the steps here. So you need some training data to put in front of these robot dogs, so they become brilliant at navigating obstacles in lots of different settings, not just the same obstacle in the same place. So I get that much. So you could do it by generating these images from the ground up, almost coding pixel by pixel the image, or you could just automate the process instead by getting a large language model to come up with not just the images themselves, but the text prompts, the things that you'd have to spend all weekend and get a load of PhDs to help you type in all weekend to come up with 1,000 different ways of describing the kinds of images you want. And that's the bit you're automating, and that's the really cool thing about your research. The end.
That's right. That's right. That's right.
You. That's so cool. What makes this so exciting for you? I know there's the bigger picture of the research, getting robots brilliant at navigating obstacles, but this language-based approach, what is it that's so exciting to you about that language approach?
Natural language, if it's not the best way, it's like one of the best ways to specify like a scenario. And imagine like you're building like a self-driving car. In our case, it's a robot trying to like go through an obstacle course. How would you describe the 3D scene, like with the kind of like season, the lighting, like what kind of scene, like what kind of like ground there is on the grassland or like cobblestone? How would you actually describe these without resort to like natural language? So it turns out language is actually the best way to specify these things. And I can see the same kind of approach that like trying to use language models to generate these like very structured dictionaries where each one of the keys correspond to a different region, and that region corresponds to a different like text description, being extended to generating a lot of diverse scenarios for autonomous driving, for humanoid robots trying to learn how to, go from a living room to like a kitchen, try to open cabinet inside those kitchen. It's very general.
So the bigger picture here is then that you found a way of automating the way that you train expert systems to deal with the scenario. In this case, you're trying to get a dog to jump over obstacles, but I guess it could be many other things. And so this is being able to train an artificially intelligent agent just using synthetic data. In this case, a dog that's never seen a real obstacle in real life ever before, but it becomes an expert at solving those problems because it's been trained on all this synthetic data. And that sounds very scalable and very transferable to almost any case where you need to train a system to get very good at doing something.
Yeah, that's right. We basically figure out a way to, if you think about compute power is the new oil, we found a way with very little human effort to convert this fuel into synthetic data. And we showed that if you do everything correctly, you can convert these synthetic data into like a real robot's capability in the real world.
All right, in the real world, that's Zhu Yang of MIT's Computer Science and Artificial Intelligence Laboratory. He's quite brainy, as you heard there. Ania, what did you make of it all?
Wow, just wow. I mean, the whole idea is just something. Can you imagine just even thinking the idea up, let alone doing it? It's beyond, I think, what most of us would ever think of. But I think, this is quite a significant breakthrough. So obviously self-driving cars is one of them. But what about more mundane situations? Chat live functions on websites.
Yeah. Improve them.
Something very, very simple, but they're not very, very good, are they? So the more training data that is available for that, the more examples that can be fed in, the better the responses would be. But what about training robots in social care?
Yeah.
It's all well to say, pick up the person who's fallen over, but the robot needs to be able to say, right, well, is there anything, can I assess this person and see if there's anything obvious that means I shouldn't move them, or I should only move them in a certain way? And I just think that even with this, you're probably not going to get every group of combinations that could possibly happen in real life, but certainly it would be significantly better than what it is now.
Absolutely. And it really is just all about just making robots more general in what they can do. And in this case, it might seem like a trivial example, and my goodness, this is not a trivial example, but it might seem like it. Hey, just get a fun robot dog to jump over an obstacle. But, the idea that it can recognise any obstacle in any setting, no matter what the lighting conditions are, or just how high the object is, or which angle the dog approaches it at, it's incredible. And I think the big important point that Zhu Yang would say, if he was sitting here, is that he's using, and his team, they're using synthetic training data. So that's the thing. So they're starting with these text prompts that go into a generative AI to produce the training images for the dog. And I know I'm repeating myself from what I said in the introduction, but the fact that none of this data that the dog is using to effectively become an expert at identifying and then avoiding obstacles, none of this data comes from the real world. This is all completely synthetically generated. And I think what Dr. Yang and his colleagues are saying is that this is a big deal, that you're using synthetic data for these real world problems. Wow. There we are. My head's hurting. Shall we call it a day?
I think so. I don't think I can cope with this anymore.
There we are.
Put me in a darkened room quickly. Oh, we are.
We certainly are. And loving it. What a story that was. So get in touch with us. Our email is hello@somewhereonearth.co, especially if you're in the AI community, because it's controversial, that thing that synthetic data can train robots for real-world applications. That is controversial. What do you think? hello@somewhereonearth.co on the email, and on WhatsApp we're code 44 7486 329 484. Leave us a voice note, won't you? We're on all kinds of social media platforms. We're quite easy to find. If you do something like SOEP or Soap Tech or Somewhere on Earth or something like that, or Mind Bending AI. And what else can I tell you? We're on the Evergreen Network, of course. So you go to their website, check out their other titles, evergreenpodcast.com. The sound production, sound design, editor function, producer, accountant and everything is done by Ania Litterovich this week, as ever. The production manager is Liz Tui, and I'm Gareth. And we'll see you next time. Bye-bye. Okay.
Hi, everyone. It's Michael Calore, Director of Consumer Tech and Culture at Wired, here with my colleagues, senior writer Lauren Good.
Hello.
And Wired contributor Zoe Schiffer.
Hey, everyone.
We're here to tell you about our new podcast, Uncanny Valley, a show about the people, power, and influence of Silicon Valley.
Every week, we get together to talk about how technology and culture from the Valley is influencing our everyday lives.
We dig into questions like, will we ever get our privacy back? Is OpenAI for real? And how are Silicon Valley billionaires impacting U.S. elections?
The first episode of Uncanny Valley comes out on October 31st. Listen wherever you get your podcasts.